Nice.
NDA, but yeah, so let's get started. I'm going to skip some of the intro slides because you already saw these in the previous week's meeting, and so far it's only you. So to me, there's no point of repeating a lot of these, but we'll go straight to the use cases and have a discussion around there. Okay. So let's just skip all of this. Again, we were in the previous week's sessions and we saw a lot of these already.
Wow.
Okay, so this session tonight is specifically to talk about use cases. I'm going to present two really powerful use cases, but DevOps is so broad. These are not the only use cases or the only case studies that you'll encounter in the real world. You'll find that there's a lot of use cases for DevOps, but I'm just presenting two specific use cases that lend itself very well with the DevOps toolkit. Okay. So the first use case that I want to present, and it's something that we're building internally, is called build factories for multi-platform and multi-cloud images. And again, I'll set up the context when we get to that specific use case. The second one is for rapid application development and deployment with immutable infrastructure automation and CI/CD, which is also automation, but for software development and deployment. And again, I'll set up the context for that when we get to that use case. So the first one I want to talk about is build factories. So what do we mean by build factories? First, let's talk about the context of a typical situation where you have developers, wanting to build software, packaging them into binaries, using programming languages like Python, Java, Node, and then producing that, and then having other developers, either from their own team or from other teams in the same company, or even external consumers who are going to use that software and that package. Now, there's a few things that we have to think about when we think about this developing the binaries and the software packages, and then sending that off to other folks. So what I want to break up in terms of the situation here is in terms of producers and in terms of consumers. So when you have a software application or a software package or a software tool or a software binary, someone is producing that software. So that's what I mean here by producer. So there's someone, a developer, in their own computer environment. Some of them are going to be developers who produce and develop software in Windows. Some of them are going to be producing software or packages in an Apple computer context. And some of them are going to be producing software and packages in a Linux context. I'm sure you're familiar with these different types of OSs. So for example, Gene, what operating system do you use for either work or at home? Oh, sorry, I think you're on mute, maybe. Yeah, I think you're on mute, Gene. I couldn't hear that. You're still on mute. Let's see. Let's see. Oh, okay. I think you're. Hello.
I was saying.
Oh, there you are. Oh,
I'm
okay.
using Windows.
Okay, you're using Windows. There you go. So you're very familiar, I'm sure, with the Windows environment and the context. I'm sure if you switched over to Apple or Linux at the beginning, it might be unfamiliar, but I'm sure if you used it over time, you'll start to see some of the nuances and differences between Windows, Apple, and Linux. So something to I just want to mention here, which you might find interesting, is that Apple and Linux, even though they're two different operating systems, they're actually part of the family of what's called the Unix family of operating systems. So
Okay.
they're different operating systems, but what you're going to find is that a lot of developers who need to work with Linux environments, they actually prefer to use Apple as their development environment as well, is because the Mac OS operating system and the Linux are actually very, very similar. So when they're developing either in Apple or Linux, it's not that much of a context switch for them to switch over here. Now, but there are also a lot of developers who use Windows as well. But the Windows and the Apple Linux are quite separate and different in terms of their environments. Now, so the reason why I bring up these three operating systems is because, again, you have developers who are the producers of software using they can use three different types of operating systems. And not only that, but to add to the mix, these days, oh, we have another participant here. These days, what you're going to find is that not only do you have different operating systems, you now have a mix of different computer architectures. I don't know if Gene and Manny, you've heard of the Apple Silicon when it got released in 2020. So that's the Apple MacBook M1, the Mac M1, M2, the different architecture that's now being used by Apple. They're moving away from Intel chips to the Apple Silicon chips. So the reason why I mentioned that is because in the past, usually people who are familiar with the ARM architecture of chips, CPU chips, are those who work with like the Raspberry Pis or like, the Internet of Things devices, because usually the ARM chips are very, very energy efficient. So the developers who use ARM in the past, before the whole Apple Silicon thing happened, were usually using it for those Raspberry Pi and those small devices. But when Apple produced the Apple Silicon chip, it's become very, very popular now for developers to also develop and make software on ARM architecture. So, for example, ARM64. So the reason why I mentioned that is now you have this matrix of not only different operating systems, but different architectures as well. Because now you can have a Windows operating system on either x86, 64, as well as on ARM architecture. And you can have an Apple on an Intel CPU chip, as well as an Apple on ARM architecture chip. Same thing, Linux can be on Intel AMD 64 architecture, or the Linux can be on the ARM architecture as well. So you have a 3x2 matrix here. So potentially six different types of environments that producers are producing software on. Okay, so you have these producers and their environments as they're producing the software and the packages, and when they produce that in that environment, you have the dependencies of the software, and then you actually have the source code as well. So when they build it, they're building it within the environment that their system is on. So whether it's Python, Java, or Node, they're building and packaging this on their computer, which acts as the builder for these binaries. And so you're going to have, for example, let's say it's on a Windows on a x86-64 architecture. These binaries, once it gets produced, it was produced in that environment. So there's no guarantee that the consumer of that software, whether it's an Apple or Linux, can consume that binary. So let's say you built this binary on a Windows x86-64 architecture. If a consumer is using an Apple Silicon, the M1, which is an ARM architecture, they actually can't run natively these x86-64 binaries. So Apple actually did this clever thing where they used this software called Rosetta to allow the M1 architecture or the ARM architecture to run x86-64 binaries in software through emulation, but it's actually not running it natively. So the point is that if you produce it in a certain type of environment and architecture, hardware architecture, there's no guarantee that your consumers can consume it if they're having a different environment and architecture. So that's one of the challenges. Same thing if you're producing on the Apple, let's say you produce it on, you build your software and your application, your binaries on an Apple Silicon M1. When you produce that, if your consumers, your fellow developers or teams from another department have a Windows x86 64, they can't directly consume your packages and binaries that you build. So that, you know, I mean, and we're talking just about one binary software, but imagine if your the application that you're building has a bunch of other software and tools in the chain, and they depend on multiple, you know, binaries and tools. Now you have this complex, you know, ecosystem where you're producing it from this one system, and there's no guarantee that consumers downstream can consume your system and ecosystem. So that's the challenge that we're talking about here, and that we're trying to resolve with, you know, DevOps tooling and toolkits. Okay, so one build environment does not guarantee that it's going to be consumable, or sorry, going to be able to be consumed by people who are using different types of environments on their systems. Okay. So one of the early tools back in the 2000s, late 2000s, that was produced by HashiCorp to sort of address different types of environments for different types of developers was this tool called HashiCorp Vagrant. These days, you're not going to be hearing too much about it because you know, there's a lot of other tools that can resolve the environment dependency, such as, you know, container technologies, but also Packer, which I'm going to show you in a bit, and the Packer workflow. But Vagrant actually for some time was actually very, very popular in the development communities. And Vagrant actually, through Vagrant, it led to Packer and the other HashiCorp and DevOps toolkits. So at the beginning, Vagrant was actually a very important tool to help developers have a local development environment consistently across different teams and across different platforms using provisioners. But anyway, the way the Vagrant works is you have this Vagrant file, which instructs your computer how to build certain virtual machine images and certain boxes, and then how to run it. However, Vagrant itself is not actually a virtualization client. It uses what are called providers. And the providers are your virtualization clients, such as VMware, or you could use VirtualBox. For people who use Mac, they would use Parallels. And so those virtualization clients are actually doing the heavy lifting when it comes to allowing you to virtualize and run your images. But what Vagrant allows you to do is have a consistent configuration file called the Vagrant file, which describes how that box, they call it a Vagrant box, how that system is going to be spun up and provisioned, and then ultimately run by your provider. So as an example, let's say in your Vagrant file, you determine that you're going to run an Ubuntu Linux operating system. So you start first with the operating system, which in this case is Ubuntu Linux. Then what you can do also in your Vagrant file configuration file is determine how the network is going to be set up for this virtual machine. And also within that virtual machine, is there going to be any initial configurations for that machine, such as, you know, users, groups, passwords, you know, SSH keys, things like that. And then you can provision that and lock that into the Vagrant box, and then send it off to other folks who, on their machines, they just run the Vagrant command line, so Vagrant up, and then what you are experiencing on your machine, let's say on the Windows, with this virtualization of this image, is going to be consistent with someone, say, on the Mac when they run this Vagrant box on their Mac. So then really quickly, you have this environment where you can quickly test virtual machines and how it's going to be run on different environments. Because you can be sure that as long as, again, there's an actual virtual machine virtualization provider from the consumer, you've already described how that virtual machine should run through the configuration file of Vagrant. So right away, it started this it's not that Vagrant started this movement, but it's part of this class of tools in the DevOps toolkit that allow for you to describe the state of how environments should be. So we're getting towards this sort of philosophy or sort of mentality of here's the state that I want my environment and other people's environment to be in, and it becomes a declarable sort of syntax. So you're going towards declarative code and programming where you say, I want the state of this environment to be ABC. So if someone else runs the ABC code or file, they should have the exact same infrastructure and the exact same environment as myself, because we're all using the same configuration file to declare the infrastructure. In this case, a virtual machine code. So again, in the top here, we'll have, say, one Vagrant box that is using Ubuntu Linux as the operating system, and then it installs, let's say, Kubernetes, say, through micro Kubernetes or micro AWS and Istio. And then one of the beginning scripts when you turn on this machine is that it forwards the port 10443 to the host OS as an example. So if someone runs this Vagrant box, right away, the first thing they can do is go to their browser, go to 127.0.0.1.10443, and they'll see this dashboard. Now, if you take that same configuration file, but now you change something like the operating system, and you change, instead of Kubernetes, you change it to use, for example, the Red Hat suite of container tools like Builder, Scopio, and Podman. But again, you still keep the port port forwarding set up, depending on what software, what application or container you're running to port 10443. When they turn on this virtual machine, it should still also forward port 10443 to their computer when they run this up. But of course, instead of Kubernetes, they'll see whatever that application is that you've installed on the AMA Linux. But now you have two configuration files that, depending on the need, you can share this with other developers or other teams, and they just run the Vagrant command, and they should have a very consistent environment that you also have. So very quickly, this allows you to develop and test using things like virtual machines. So we're not talking about containers. Containers are the lightweight counterparts of this, but we're talking, about virtual machines from configuration files like this. So it becomes a very, very powerful part of your workflow. So this is the example of Vagrant. But like I said, these days there's a lot of other alternative tools, and I'll talk about Packer in the next slide. But most people are probably going to do some quick testing if it doesn't need to be done on a virtual machine. They'll probably just use containers like Docker to quickly spin up a web app testing environment. But if you're doing some heavy duty things like testing on actual server types of virtual machines, then you can still use Vagrant as an option for dev and testing. Okay. Sorry, any questions so far regarding Vagrant and sort of the problem it's trying to solve, or any questions about this diagram architecture or the workflow itself? Not, I'll move on to the next build factor. Oh, sorry, Gene, you have a question?
Yes, based on the starting point where we were having like those OS, starting here. So I don't know, as a DevOps, I don't know, is that in a company where do you have like that transition, because you are having like a code coming from this, and then you use like maybe Kubernetes, or I don't know, do you have another application to, I don't know, like the way I'm trying to explain is like when you go through Windows, and then maybe the end user will use like Apple or Linux. I don't know how to convert those. I don't, you just show like the coding, like the port to access the application. I don't know. Is there anything else we can use to convert, like? Oh
yeah, so like I mentioned, so you mentioned Kubernetes. So yeah, that's one option, containers. So Kubernetes is a container orchestration tool. So if you're not having fleets of containers and you're just running one or two or a couple for testing purposes, you're probably just going to use Docker or Docker Compose as your local dev and testing environment. But once you're running fleets of containers, especially in production, you're going towards Kubernetes. So the container solution is one option to use if you want to have a consistent environment that can be run across different operating systems like Windows, Apple, and Linux. And the way that works is that what you do is you refactor your code so that it works in a container environment as a container image. So instead of building, say, a virtual machine image that I showed with Vagrant, what you're doing is, the purpose is, since you're just trying to run web apps consistently across different environments, you use what's called the container image. The container image describes all the instructions necessary to run a container off of that container template, the image template. So for the other solution is the virtual image, like I mentioned. So virtual images are going to be used for if it's not just a simple web application, but it's something like you need to test software, code, libraries, dependencies in a full-featured virtual machine, in a full-featured operating system. So it's not enough to just have, for example, the container to run a web app, but you want to test everything from users, groups, permission, security on the virtual machine as well. Then containers wouldn't be enough for that. These days, some folks are trying to create lightweight operating systems. So it kind of mimics like a virtual machine, but you package all of that in a container. But that still does not replicate fully or emulate real virtual machines, because there's a lot of things that are in the container that are limited and constrained that you can't replicate fully what a virtual machine is like. So the virtual machine environment. So my recommendation is, you don't have to just use one or the other, depending on what the situation is. The modern tech stack these days is you're going to have a mixture in your production environments and also your dev environments in an organization or business, where you have virtual machines running alongside container technologies. So you have virtual machines and you have container technologies. The other thing is, sometimes people forget, in order for you to run your containers, there has to be a virtual machine or a bare metal server that's there first, and then you install container technologies on top of that. So what if you wanted to test building out the Kubernetes platform? You don't run the Kubernetes platform in a container. What you actually do is you install the Kubernetes on a virtual machine or on bare metal, and then you run containers on top of the Kubernetes. So there's that 3-layer stack. So you still have to test virtual machines as well, right? So in that ecosystem, you actually have to have the ability to use virtual machines and to use containers. And something that's really neat, I didn't mention in the Vagrant thing, is that people also build, as an example, Vagrant boxes that are Amazon Linux 2 boxes. So for example, one way for you to test out and develop on AWS Cloud is to spin up Amazon AWS EC2 servers in the cloud, and then SSH into that server and do your development within that AWS server. However, that does incur costs because you could use a free tier, but you get 750 hours of T2 micro per month with AWS. If you run a Vagrant, so let's go back to here. If you set up the Vagrant, if you set up the Vagrant box for Amazon Linux 2, so there are folks who have already created these ready-to-use Vagrant boxes for Amazon Linux 2. What that means is, instead of you having to spin up an Amazon Linux 2 EC2 server on the AWS cloud, you can actually download the Amazon Linux 2 image virtual machine straight to your computer, your local development environment, and just start testing using Amazon Linux 2 operating system straight on your computer through, for example, Vagrant. There's other ways you could do that as well, not just Vagrant, but I'm giving you an example of how tools like this allow you to quickly develop and test something like Amazon Linux 2, which, had there not been these types of tools, you would have to, use AWS's EC2 server and infrastructure, spin up the server on the cloud, and then potentially incur costs. Whereas if you do this locally, there's no cost to it, right? You're just developing and testing. And then when it's ready to go and you've gone through that iteration and workflow where you've tested, everything works, then you start spinning up those real AWS EC2 servers in the AWS cloud, but it's already ready to go because you've tested it locally without incurring costs. And then when you actually have to deploy it, then that's when it, start incurring costs. But at that point, you've already done hours of testing locally at no cost. So it gives you that rapid development and testing workflow. That's an example. So that's like 3 different types of solutions for a situation like that, Gene. But does that kind of make sense in terms of how you'd approach something like this?
Yeah, I got it. Thank you.
And yeah, no problem. And the thing is, one of the things I like to say is you have to kind of go through the pain first in order to appreciate, how powerful these tools are. So let's say if we didn't have Vagrant, or we didn't have, these DevOps toolkits and the things to let us automate. Imagine you had to manually do all these things for, I don't know, 100 servers without all these DevOps automation tools. Go through that once first, and then you can appreciate, how powerful these DevOps tools are, and then how much easier it makes our lives. This is actually one of the coolest, I feel, one of the coolest use cases for something like a DevOps tool or tooling within the DevOps ecosystem. So, it's missing the Kubernetes and Istio, but imagine take these 2 icons and just put it over here. For some reason, didn't pass over on this slide. But so on the previous slide, I was showing Vagrant, and we're building a very simple use case here where you're just trying to get up and running a virtual machine to do your dev and testing. Now, imagine this. Let's say your organization doesn't want to just work in AWS, doesn't just want to work in Azure, doesn't just want to work in Google Cloud. It actually uses all 3. So you're working in an organization or business where it's a multi-cloud infrastructure, and you have to provision servers across 3 different cloud providers. So you have AWS, Azure, and Google Cloud. Now, within AWS, Azure, and Google Cloud, they each have their virtual machine or image registries and the ability to launch from their image stores. However, your company needs custom images, and these custom images have to be consistent across all 3 providers, cloud providers. So one thing you could do is first go to AWS, download their specific starting image, and then custom write all your installations, all your patching, things like that. Save your image and then re-upload it back to AWS, and then you have that one custom image you built on AWS registered. Now you have to go to Azure, do the same thing, download from their base image, write up all the custom code. After you've done doing all the installations, re-upload it back to Azure. You've registered in their image registry. So now you have your second copy or your second clone, but really you have to do it twice and 2 different ways. So it's not exactly a clone. Same thing with Google Cloud. Go download their base image, whatever their base image is, and then do the custom installations, re-upload it back to Google Cloud, and then also document all somewhere. What if you had a way so that starting from one base template, you build all your provisioning infrastructure, you codify it, you have one consistent configuration file, and then through that workflow, it then publishes to all 3 cloud vendor providers in one go. And then from there, you also then provision those servers from that same consistent template or base image. That provides a very, very powerful tool so that now, instead of having to manage 3 different workflows just for the same exact image, it just happens to be that it's going to be in 3 different cloud environments. You start with one workflow that then produces 3 different endpoints for your for your image, okay? So let's walk through this and see how this actually works. So at the beginning with this tool called HashiCorp Packer. HashiCorp Packer is a very powerful tool that it's basically an image building tool. So that's why I'm calling this build factories. So you build your image with HashiCorp Packer using this code file called a Packer file. It's called a Packer file. So in this Packer file, what you do is you describe what your base image is going to be, and then you describe how you want the configuration in that image to be. So for example, let's say you start off with Ubuntu 22.04. That's your base image. From there, you tell Packer, listen, in the Packer configuration file, hey, listen, take this base image Ubuntu. I want you to install Ansible. I want you to install Docker. I want you to install Kubernetes. I want you to install Istio. And then I want you to upgrade to the latest updates for February 15th, 2023. And then you freeze that image. You have that one base image, not base image. You have that one custom image that you created for your company, okay? So that's where this thing is. Packer will produce that, will build that, and then produce this. It'll load it into your 3 providers. So it'll load the same image. It'll load it to AWS, Azure, Google Cloud, because this is your custom image, so you can load it anywhere you want. So let's say we do Ubuntu, we load it into AWS, Azure, and Google Cloud, okay? And then what you do is, and I'll talk more about infrastructure automation tools later. That's the second use case, but here Terraform is what's called an infrastructure as code tool, which allows you to automate immutable infrastructure. So basically what Terraform does is similar to Packer through code. You tell Terraform, I want you to build this infrastructure in AWS or Azure or Google Cloud. It's able to do any because it has these what are called plugins or providers. And using those plugins, you can quickly deploy, for example, cloud networks, cloud servers, anything you want. So in this case, we're saying we want to tell Terraform, hey, listen, Terraform, I have this custom image I built using Packer. It's in AWS, Azure, and Google Cloud in their image registry. Take that using the ID that you created. Let's say you created this custom image and you gave it ID 457BB23, something like that. You tell Terraform, go grab that image from each of these cloud providers and spin up 2 EC2, in AWS, it'll be called EC2 service. Azure, it'll be called like compute machines or something. Google Cloud, it'll probably be called like some compute thing, but all cloud providers have the exact same similar services. They're just named differently, so they don't, I think, get into legal infractions or something like that. But anyway, so on AWS, it's called EC2 server. EC2 instance. On Azure, Google Cloud, whatever the equivalent is. You're telling Terraform, take this custom image, they're all ready to go in AWS, Azure, and Google Cloud, spin me up 2 instances, 2 virtual machines in the cloud in each of these clouds. Then now you have 6 virtual machines running the exact same software, image, and everything across 3 different clouds. And it could be for the reason why you need those 3 different clouds is for security, compliance reasons, who knows what it is. Different organizations and businesses have different reasons for doing that, okay? And so that's one image that you've done, but you could do the exact same thing with a different Packer file. This time, instead of Ubuntu, let's say in the Packer file, you say start with Alma Linux, which is another type of Linux distribution. And in it, install Builda, Scopio, Podman, get this custom image ready to go, install it, register it in AWS, Azure, and Google Cloud. Using Terraform, now spin me up 2 instances each in AWS, Azure, and Google Cloud with this custom image ready to go. And now you have 6 servers running Ubuntu Linux with Kubernetes, Istio, and 6 running Alma Linux with Builda, Scopio, Podman across 3 different cloud infrastructures. And all you had to do was build 2 configuration scripts or two files with Packer file. And this becomes extremely powerful because I haven't even shown it here, but combining this workflow now, you could also add something like Ansible to the mix. And now Ansible, let's say you add it here in this step, Ansible will, you register all 12 servers in your Ansible playbooks. And now Ansible can control these through, for example, a command center. And Ansible, let's say you wanted to patch all 12 servers with a specific update or something like that. Using Ansible, you can automate that without you having to go to manually each of these servers and do it yourself. You just, through the Ansible playbooks and modules and agents, you can force Ansible to, maintain and configure and update 12 different servers. And now you're combining Ansible into this workflow of Packer, Terraform, and this pipeline becomes extremely powerful. And then going back to what we talked about in the previous slide, Vagrant, remember how Vagrant allows you to spin up very quickly a virtual machine environment and just do dev and testing? Imagine that before you go and start building this pipeline, what if you're like, wait, I want to see what it looks like in Ubuntu Linux with, the Kubernetes and Istio, or I want to see what alumni Linux looks like with Build a Scorpion Podman, and that it actually works. Before you actually go and build out this custom image and push it to, your 3 cloud providers and stuff, what you do is you use Vagrant to quickly test this setup, using the Vagrant file and doing all those installations and quickly checking. So within a day, less than a day, you could quickly see and test and prototype whether this whole workflow that you're planning to do and designed, is that actually going to work out the way you expected? And you can do all this in less than a day using a tool like Vagrant, because it allows you to quickly spin up those virtual machines in different contexts. And then you can quickly test and provision your virtual machines accordingly. And then you can run this through the pipeline because you've tested it with Vagrant very quickly in a few hours. Okay, so this becomes a very, very powerful workflow for developers and DevOps teams. Dev and testing in Vagrant, and then push it out to Packer and Terraform, and then manage and maintain and configure afterwards with Ansible. Very, very powerful. But does that make sense so far, Gene and Ramya? Any questions about the Packer build factory? No? Okay. Or Gene, were you gonna say something?
So based on these two, let's say 2 figure, we can run this using Vagrant directly, or we can do it using the Packer file. Is that
correct? Yeah, yeah.
Okay.
So you can do either way, but the Vagrant is actually a quicker way to do the dev and testing. You can get it up and running very quickly. Usually with Packer, the end goal is actually to build an image that you push to, for example, AWS, Azure, or Google Cloud. So if you're using Packer, usually by this step, you're pushing your custom images to one of these cloud providers and then provisioning those images with Terraform as an example. With Vagrant, usually people these days with the modern tech stack evolutions and stuff, they don't usually go to production with Vagrant right away. They use Vagrant for dev testing purposes, and then if they're ready, they start deploying with Packer and Terraform.
So is that part of the cost, management, or
Sorry,
when we use Vagrant, is to reduce the cost? Okay.
Yeah, it's sort of like more for dev testing purposes. Yeah. Now, the next use case I want to talk about is actually a very, very common use case. In fact, one of the reasons why people get into DevOps or are interested in DevOps in the first place is because they're already building web applications and they're trying to figure out tools and applications that can help them with their application development and deployment. Because ultimately, if you think about it, software, tools, and technologies, it's you're ultimately deploying a web app that's going to be consumed by your customers. Whether it's a web page, a website, or whether it's a online tool, it's some sort of application web app that's going to be consumed over the internet, ultimately, for the most part. So where does DevOps and CI/CD come into play? So let's take a very typical tiered application setup here. You'll have a front end. So for example, here I'm for demonstration purposes, I'm just saying React, but again, it could be anything. It could be Angular, it could be Python, it could be whatever front end tool that you prefer. Then in the back end, the way these modern tech stacks are going these days with microservices and APIs, almost everything is an API call these days. So machines talking to machines, they talk through APIs, which are application programming interfaces. So this is, for example, when you make a HTTP request to a server, and the server will give you a response, whether that's a web page or data somehow, gives it back to, for example, a web browser or just a machine, other servers that need to get data from other servers. So the backend usually is powered through APIs, okay? And these APIs themselves go to a database somewhere. So it could be database servers that store data. And these APIs make calls to these database server backends and grab those the data and then return that. The backend services then return that back to the customers. Okay, so you have this relay of information back and forth. Now, with the way the microservices and infrastructures work these days, these can independently be their own servers and services that themselves can be independently developed and tested and run in production, things like that. So one does not have to depend on the other. So the way we can think about this is, although I should have displayed here, but even with the databases, you can have a dev, you can have a stage, and you can have a production phase for each of them. Okay, so usually in dev, that's when you're developing and actively developing. You're gonna have a lot of bugs and all that stuff. And then through testing, multiple rounds of testing, you get rid of the bugs and then eventually get to a staging environment. The staging environment is where the way that you want to think about this is staging is kind of like a dress rehearsal for like a play. Like, when you go see a play, like a Shakespeare play or something, when you as the customer go there and purchase the ticket, what you see is the production environment. What you see is, that's like they've done all their testing, they've done all their practice and stuff. You see the actual production quality theater playing. What you didn't see is the night before, they might have done a dress rehearsal as close as possible to what that play is going to look like in production in the actual day of theater. So staging, the way to think of it is it's as close to production as possible, but it's not actually production. It's the same thing as a dress rehearsal. It's as close to the actual play itself on the day of the theater play, but it's not the theater play itself. Okay, so here in staging, you're just trying to get all the, there might be minor bugs that still have to be taken care of. You're just making sure everything looks good before you pass it on to production. Sometimes this might require manual approval before the updates and changes and patches and releases get pushed to production. Sometimes it might be automated. It just depends on the QA setup that the business and the organization has. And with this dev stage prod, again, since in this microservice architecture we have set up, each of these can have their own dev stage prod, whether it's a front end application, a back end, or the database servers themselves. Okay, so every component can have their own dev stage prod. And the reason why this is quite powerful, this approach, is because you could have a huge team, or you have many smaller teams, and they can each themselves be focused on one application and one service. So, you can have a team that's specifically focused on front-end development. You could have a team specifically focused on these APIs, and you can have a team just focused on developing and testing and managing the database servers. And as long as they do their part, these microservices can run independently of each other. And you can be confident that if they also have these, dev stage prod set up correctly, they've done their due diligence, and this service is talking to this service, it should work as expected. This should work as expected, etc. These teams are going to independently work with their own setups. Okay. Now, I want to quickly show like how as an example, how a typical application with, say, the front end and the API services are going to be deployed in AWS Cloud as an example. Typically, you have your load balancer sitting in a public subnet, waiting to accept requests coming from, your external customers or your development teams, including DevOps. And then you have the application load balancer then forwarding those requests to the backend servers, whether it's the web app servers themselves, or it could be database servers that are sitting in private subnets. Okay, so the private subnets don't have a public IP address, and so people can't just all of a sudden, access these servers. One way to, if you're a developer or you're the DevOps member, if you want to access these private servers that don't have a public IP address, the way that you could access a application load balancer is you could use the classic strategy of bastion hosts. And a bastion host is basically a EC2 server sitting in a public subnet that forwards your SSH tunneling, and it does like what's called SSH hopping. And it knows the specific IP addresses that are for the private servers, and it has security groups set up so that the firewall set up so that the bastion host itself can access the private servers. So that's the classic strategy. The other strategy these days, the more modern way to do it, and I'd say the more safe way to do it, because sometimes with bastion hosts, some people forget their SSH keys in the bastion host servers, which can lead to a security issue as well. But the more modern way to do this is use, for example, AWS has this thing in the systems manager service that allows you to access your private servers straight from AWS. So even if it doesn't have a bastion host in the public subnet, or there's no other way to access it from a public subnet, you can access these private servers using AWS's system manager setup. Okay, so that's a system manager connect or something like that. But that's the more modern way to do that these days. But anyway, so this is a typical setup for having your EC2 servers behind or your backend servers and databases behind a private subnet, and then a load balancer sitting in the public subnet forwarding those requests to those backend servers. Now, what does this have to do with DevOps and rapid application development? So the reason why I wanted to show you these setups is because instead of let's say you had this setup, let's say this is the template setup, but imagine you had 3 different types of environments that you wanted to set up for this particular setup, but multiply it by 3 times, and then do that. Let's say multiply that by 5 times for 5 different applications that your team is responsible for. You could go in AWS or use the AWS CLI and spin up each of these components yourself. So what you got 1, 2, 3, 4, 5, 6 different subnets, mix of public and private. Then you got these auto scaling groups with the EC2 servers. And then you got to have the application load balancers, and then you got to set up these certificates. And so, we're talking dozens of infrastructure components at this point. And then if you had, like I said, times 5 and then times 3, that's a lot of things you'd have to set up manually yourself. Okay. What you can do using a DevOps tooling, such as infrastructure as code, in this case, you could use, since it's AWS Cloud, you can use either Terraform like I showed in the Packer workflow, or you could use, AWS has its own infrastructure as code tool called CloudFormation. You could use CloudFormation and set up your CloudFormation infrastructure stack configuration files so that it knows how to spin up, for example, your whole network infrastructure. It knows how to spin up your whole launch template. So launch template is basically the template that allows the auto scaling groups to generate the same EC2 servers. So within its auto scale group, okay, so that it's consistent across the auto scaling group. And using CloudFormation, you can also write up the configuration and the setup for an auto scaling group, as an example, that can spin up and spin down, depending on the request and the resource needs. And also the application load balancer. You could write this in a template, and using these templates, we got 4 templates here, but there's going to be more templates depending. It can be more or less depending on your needs or your setup. You can multiply this 5 times or 3 times or 10 times, 12 times, doesn't matter. You could, because you have this template, you can run as much infrastructure as you want, spin them up and then spin them down, tear them down as needed. For a typical infrastructure setup, this might take no more than 10 minutes to bring up this whole infrastructure in an automated fashion, literally just one command line, just say, you know, CloudFormation create stack, and then it creates this whole infrastructure for you within minutes. If you did this manually, could take up to 1 hour, could take up to 1 hour to input all the correct things. Now, of course, some folks will say, well, I'll just write a bash shell script with the CloudFormation with the AWS CLI with CloudFormation command line tool. Yep, you could definitely do that. But the thing about bash shell scripts is, it's for what it's worth. Creating these YAML configuration files, it's a lot more consistent and readable compared to running a bunch of bash shell scripts. Different people will have different styles of how they write their bash shell scripts. Some people are really good at writing bash shell scripts, and it can look very elegant. Vast majority of people are not going to write beautiful, elegant bash shell scripts. With configuration templates written in JSON or YAML that, for example, CloudFormation enforces you to write in a consistent manner, you could have different people write these CloudFormation templates, but it's going to look very, very consistent and very, very similar, very readable. So you have to keep in mind, it's not just you. In fact, most of the time you're working in teams, other people have to look at your code. Other people have to look at what you've done. And the more we can get towards a place where whatever code you're writing is more consistent, more readable, it just makes it easier to maintain for future developer or future folks who are going to take on your projects or use your code as a launching pad. So again, of course there are different ways to do this, and wizards of bash shell scripting and stuff can get away with building all these things, but not everyone's going to be able to maintain and patch together all these shell scripts. With tools like infrastructure as code, it's trying to get towards a place where it's more consistent, more maintainable, more scalable, and less buggy. It's not perfect, of course, but I think it gets us to a place where we can get more consistency across development teams as well, DevOps teams. Okay. So and the CI/CD part of this is, like I mentioned here, during the dev stage and prod, you can use tools like Jenkins, GitHub Actions. In AWS, it's called AWS Code Pipeline. But the idea is that every part of dev stage or prod, and every part of this testing all the way to deployment, you could use tools like Jenkins, AWS Code Pipeline, or GitHub Actions to dictate what are the conditions that have to happen before it moves from dev to stage, or from stage to prod, or from build to test, etc. So just using code similar to the CloudFormation stacks, there's going to be a template or configuration files that determine how the CI/CD is going to happen. So as an example, GitHub Actions uses YAML to dictate how the CI/CD structure is going to work. Same thing for AWS Code Pipeline. If you write the Code Pipeline CI/CD configurations in CloudFormation, you could use CloudFormation to dictate how the CI/CD for AWS Code Pipeline is going to work. So the build stage, the source, all the way to deploy. And it becomes a very, very powerful combo of IAC, infrastructure as code, with CI/CD. Okay. So that wraps up the two very, very powerful and actually very common use cases in DevOps. And I mentioned this to Gene earlier, but I think Ramya, you weren't here when I was saying this, but the rapid application development and deployment with immutable infrastructure automation and CI/CD is actually something that we're building out for a client right now, using this setup. The build factories for multi-platform, multi-cloud images. This is what we're building out internally for our infrastructure stack right now. But so these are actually use cases that are being actively developed and deployed in practice right now. Any questions? Or I think Ramya, did were you saying something, or I think you?
Yeah, I was just saying I just missed the first 15 minutes part of it. Like
Oh.
anything important, like you can tell me in brief what happened in the first 15 minutes?
Yeah, so interestingly, because Gina was here for my previous sessions as well, I was going to go in the first few minutes to talk about the introduction to WeCloudData and what DevOps is, but I gave this same spiel to Jean last week, so that's why I skipped this and started straight in the Packer build section. Sorry, Ramya, did you come here when I started talking about Packer and Bake?
Yeah, I came when you started talking about Packer, yeah.
Oh, perfect. Okay, so Ramya, what I can do is, because I did this for the previous session with Jean as well, I'll send these slides to you both, and then that way, Ramya, for the parts that we didn't go over because Jean and I already went over this previously, you can look at some of the slides for the introduction to DevOps, and then if you have any questions there, you can reach out to me and I can answer those.
Sure. So
Yeah.
this takes place every week, like you keep this meetup every week?
Not every week. I think so. Right now we have a upcoming boot camp that's about to start in a few weeks, 2 or 3 weeks time. So these sessions is just to help build up the context of why DevOps is important and why folks are using DevOps. And so if you're interested, for example, you can inquire more and reach out to myself or our program advisors to understand how the DevOps bootcamp works and what you can get out of it. The previous sessions, for example, I had a session about 2 or 3 weeks ago where I dove deep into all the we call it the modules of the actual DevOps program itself, and what you learn in the program. I think last week we went over the job market in DevOps, and then this week is going over use cases. So there's a sort of a natural progression. You think about what's the job market like, and then you think about how is it actually being used in industry and in practice, and then also like what does this DevOps program teach? Of course, we're not the only program that teaches DevOps, but I guess some of what we teach might be unique or different that you don't get in a self-paced learning course or something like that.
Okay.
But yeah, so Ramya and Jean, I'll send you over these slides, and Jean, sort of like what I mentioned in the previous week, if you have any questions or if there's any interest in the DevOps program here at WeCloud, just feel free to reach out to myself or our other program advisors. I'm more than happy to help. And actually, in order for me to send out these slides, Ramya, Jean, if you want, you can send me a quick email at this email. And actually, it's missing the A at the end. You can send me an email here, and then I'll respond with the slides. That way, if you're not comfortable with sharing your okay. Jean's sharing email here. But Ramya, if you're not comfortable sharing your email in this group, you can always send. Oh, okay.
So, that's okay.
Because sometimes folks are not comfortable sharing their emails.